Hello and welcome. This is Michael Annis, and you are listening to episode 94 of the Space Rocket History Podcast. And now, Soyuz Development, Part 3. Recapping from episode 93, Korolov's complicated circumlunar flight involving a new Soyuz A 7K spacecraft, a Soyuz 9K booster, and a Soyuz 11K tanker has been canceled. Instead, he is working on two new spacecraft, the Soyuz 7K OK, which is intended for Earth orbital flights, and the Soyuz 7K L1, which is being used with Chalomey's Proton booster for a circumlunar flight. OKB-1 is also working on the upper stage booster for the Korolev-Chalomey circumlunar flight. In the first half of 1965, Korolev assigned the cosmonaut and engineer Konstantin Feoktistov to supervise the design work on the new Soyuz. Arguments immediately flared up over the motion control, rendezvous, docking, onboard complex control systems, and problems of the electric power supply and distribution. Also, after Voskhods 2, an ideological vacuum, a disorder, and a vacillation cropped up in the Soviet manned space program. There was no clear-cut answer to where the priority should be. Should the priority be on a new series of Voskhods, or artificial gravity experiments, or the construction of Soyuzes? But during August 1965, the wavering ended over settling the priorities. First priority was given to the Soyuz. A real all-hands rush job to develop and manufacture Soyuz got underway. A new, unrealistic schedule was created that required OKB-1 to supply 3 Soyuz flight vehicles ready for testing in December of 1965 and 1 in January of 1966. To make matters worse, in August of 65, the U.S. launched the two-seater Gemini 5 into space. In it, astronauts Gordon Cooper and Peter Conrad set a new flight duration record, 8 days. The Soviet monopoly on space records had been dealt a serious blow. The successes of the U.S. space program were very painful for Korolev to endure. The fact that he was not well made things seem worse. Now let's talk a little about the cosmonauts flying these new Soyuz. The Soviets had a very ambitious start to the Soyuz mission planned. The program stated that the very first Soyuz must rendezvous and dock. One vehicle would carry 1 cosmonaut and the other 3 cosmonauts. In the event of a successful docking, 2 of the cosmonauts would transfer through open space from one vehicle to the other and return to the ground with a different crew. In August of 1965, Korolev summoned cosmonaut trainer Nikolai Kamanin to his office, and they had a serious discussion about cosmonaut candidates for the first 2 Soyuz flights. After his meeting with Kamanin, Korolev confided to Chertok that Yuri Gagarin was also in training as part of the Soyuz flight crew. Chertok remarked that the cosmonauts still needed a good year to train for their flight on the Soyuz. To say the least, Korolev did not appreciate Chertok's comment. He told Chertok, quote, "If that's the case, we'll shut down our work on the record-breaking Voskhods, but I won't allow the Soyuz deadlines to be disrupted anymore." End quote. At the Air Force's insistence, OKB-1 factory director Turkov had been ordered to produce a batch of Voskhods. Voskhods 3 was supposed to reclaim the flight duration record from the Americans. It would have carried 2 cosmonauts on a long-duration flight of about 18 days. After Korolov's death, the mission was completely forgotten, and the OKB-1 factory never seriously returned to the construction of new Voskhods. Instead, Soyuz development prevailed. Now let's return to the development of Soyuz. The greatest difficulty encountered with Soyuz development was unquestionably the rendezvous and docking. OKB-1 didn't start serious work aimed at producing a rendezvous control system until early 1961, when Rauschenbach's Space Flight Controls Group transferred there. Around the beginning of 1963, when discussing the problem of controlling the multi-launch Soyuz complex for the circumlunar flight, OKB-1 reached the conclusion that rendezvous control must be an integral part of one of the modes of the overall motion control systems. Therefore, it was decided OKB-1 must be the head developers of the entire rendezvous problem. From the very start, it was clear that the onboard equipment could be simplified if OKB-1 included an already existing ground complex and its ballistic centers in the rendezvous control process. In this case, the distance and relative velocity between the 2 spacecrafts inserted in orbit at different times, and perhaps from different launch sites, was to be reduced to the minimum value with the help of the ground command and measurement complex, using the tried and true principles of orbital correction via commands from the ground. But the ground control method of rendezvous at best could only bring the spacecrafts within a distance of 20 to 30 kilometers, depending on how lucky you were, and the spacecraft would be at this distance for a short period of time, and then, once again, it would drift away. To prevent this from happening, as soon as the far approach phase was completed, the onboard autonomous system, which was independent of the ground-based measurements and command system, would come into play. Radio lock-on would occur when the autonomous systems detected one another at a range of at least 20 to 30 kilometers. The spacecraft would catch sight of each other and then execute rendezvous and final approach autonomously, without ground participation. At this point, one of the vehicles is considered to be the active vehicle. It moves toward the passive vehicle, which must turn with the open base of the cone toward the probe of the active vehicle. 2 types of control were possible during the autonomous rendezvous and final approach segments: purely automatic, without human intervention, and manual, during which the cosmonaut, using the system's measurements results and his own observations, uses the controls to fire the docking and attitude controls engines and brings the active vehicle to the point of docking. The Soviets decided to make it their primary task for Soyuz to execute rendezvous in automatic, unpiloted mode. Unlike the NASA approach that required astronaut participation in the docking and an onboard digital computer that the Soviets did not have. The Soviet method of rendezvous used the experience of homing missile systems coupled with ballistic spaceflight and proposed the line-of-sight rendezvous method, or simply the parallel rendezvous method. With this method, the role and the responsibility of the onboard relative motion parameters measurement system increased. This required the precise measurement of several parameters: the relative range between the vehicles, the rate of change of this distance, the rate of approach or back off, and the angular rate of rotation of the line of sight. This information is fed to the analog electronic instruments, which do not have an onboard digital computer's ability to predict the relative motion and foresee the consequences of corrections during a prolonged period of time. Therefore, the onboard instruments controlling rendezvous will turn the spacecraft throughout the rendezvous process and issue commands for small but frequent correction burns in order to bring the active vehicle inside the calculated corridor of relative rate values, which change depending upon the range. During the rendezvous process, the active vehicle not only accelerates or brakes, but must also make lateral correction to reduce the line of sight angular spin rate to 0. As the range decreases, the relative rate of approach must also decrease. In final approach mode, to keep from breaking the docking assembly, rendezvous had to take place at a relative speed of 5 to 7 centimeters per second, and the relative angular rate had to be reduced to a minimum. To accomplish this feat without relying on an onboard digital computer, the Soviets decided to use all the potential of pure radio engineering and began the original design of a phase system. Thus, the Igla, which means needle, is spelled I-G-L-A, radio measurement system made its name in the history of cosmonautics. However, during its 12-year life, it caused its developers countless hardships, joys, and numerous problems accompanied by reprimands from the minister and being called out on the carpet at the Kremlin. Igla 1 was developed for the active spacecraft and Igla 2 for the passive. The first Iglas began their work after the active and passive vehicles came within 25 to 30 kilometers of each other. The active Igla required the installation of 3 antenna arrays on the Soyuz. First, the scanning antennas, which operated in the preliminary rendezvous partner search mode. Second, a gyro-stabilized antenna, which, after detecting the partner, set up the automatic tracking mode using the passive Igla's responder and tracked it as its own spacecraft executed attitude maneuvers. And third, special antennas for the final approach. After the vehicle's orbital insertion, 5 different antennas were deployed for Igla alone, and in all, the first Soyuzes had so much varied radio technology on board that they required 20 antennas. When Korolev saw the drawing, he said, quote, "Instead of a piloted spacecraft, you've made a veritable antenna carrier for me," end quote. Aside from the number of antennas, Korolev was particularly unhappy with the complicated structure that was called the roof. This roof protected the Igla's receiving antennas against radiation reflected from the spacecraft hull. Everything that the Igla antennas transmitted and received passed into the transmitters, receivers, amplifiers, signal processing units, and devices communicating with the ground's calculation units and telemetry units. After establishing radio contact between the active and passive vehicles, a closed, autonomous loop controlling the 2 vehicles was formed. The ultimate objective of this loop was to carry out rendezvous until receipt of the contact signal. Upon receiving this signal, Igla shut down. To sum up the planned Soviet rendezvous process, first, ground-based radar and other ground-based tracking systems were used to move the active and passive spacecrafts to within 30 kilometers of each other. From there, the IGLA radio control system was used to close the distance and to dock. When Korolev was informed of all this, he listened very attentively and with great interest about the system's operating principles. Questions tended to deal more with the status of specific issues, particularly the manufacture and developmental testing of equipment. In the meantime, TASS reported that Gemini 6, carrying 2 astronauts, was set to launch on October 25th, further stirring up Korolev's interest in the rendezvous problem. It was announced that the primary objective of the flight would be to attempt to dock with the Agena target vehicle. If the American experiment was successful, then it could be a heavy blow to the Soviet prestige in space. But the next day, Korolev telephoned Chertok in a good mood. He said, quote, "The Americans' docking attempt failed. Something happened up there with the Agena. It didn't go on orbit." End quote. As 1965 progressed, Korolev grew concerned over the delays of the Soyuz development. He was so busy on other projects, he was forced to trust his deputies for information. But the deputies had made mistakes, and Korolev chewed out each one of them whenever he saw them. But Korolev knew the mistakes were part of the learning process. That's what he told Smirnov at the Military Industrial Commission when they wanted to get rid of Chertok for the YE-6 lunar soft landing failure. So Korolev was loyal to his subordinates, but very hard on them. Finally, Korolev had enough of trusting his subordinates and decided to go light a fire under everyone involved with the Soyuz project. But to do this, he had to lay aside many important issues, like the latest emergency hard landing of the YE-6 on the Moon, a cutback in funding for the N-1 program, the emergence of Chalomy's competing UR-700 design, disruption of the housing construction schedule, dozens of tragedies and requests made at private consultations, preparations to receive the latest in a series of party activists, difficult tests on the solid-fuel RT-1 missile, and hundreds of problems ranging from minor to very major. It was also noted that lately in meetings, Korolev had not concealed the fact that he was tired, very tired of this incessant race, dozens of phone calls per day over the Kremlin hotline, reports from 2 firing ranges over the high-frequency phone lines, complaints from the lead designers about schedule disruptions, and a never-ending stream of letters marked secret, top secret, and high importance. Yes, if each letter addressed to him and each report had been read cover to cover, he would have had to sit in his office 20 hours a day, 7 days a week. So Korolev dropped everything and took his deputies on a visit to the developmental lab NII 648. Indeed, this visit by Korolev and his entourage went down in NII 648 history as an event that sharply accelerated the development of IGLA. Korolev listened to the excuses from various managers claiming they were behind because the Institute's management had started this project half-heartedly. Things were also bad in production. The factory was swamped with other orders. Korolev's inspection team went from laboratory to laboratory. In each of them, individual panels that were ready for demonstration were lying on tables, stands, and workbenches. Mock-ups assembled for experiments were hooked up to oscilloscopes. In one of the laboratories, after picking up an open electronic unit from the table, Korolev asked, quote, "Is this just for show, or is it already a finished unit?" End quote. The technician replied, quote, "It's a mock-up that we use to optimize parameters, revise and correct drawings, and then we send them to production to produce the flight model." End quote. Korolev asked, quote, "So when will you give me the finished instrument for vehicle assembly?" End quote. The reply was, in about 5 or 6 months. Korolev was now beginning to get a little disturbed. He said, quote, "So that's it. I'll be going now. I'm leaving your comrades who have already been deceiving me for 6 months, assuring me Igla could be completely ready in just a little while. Supposedly, only these evildoers from military acceptance are finding fault, and that's why production is lagging. If they were deceiving me, I will take care of them myself. And if you really said that, I won't work with you anymore. I need a system, no later than December. Either you work at our pace, or we will find others. The Americans are finding a simpler solution to the problem. An astronaut is controlling rendezvous, and they don't need such a complex system. Maybe we can do without the Igla altogether. Other developers are promising us a simple system for operation with a human being immediately." End quote. There were several similar harsh criticizing performances in various laboratories. Korolev wanted to really heat up the situation in such a way that the people who really felt it were not the handful of managers, but rather the many dozens of engineers who, with undisguised interest and excitement, were seeing and hearing the legendary chief designer for the first time. The last stop on the inspection tour was the antenna laboratory. Here, the laboratory chief stole the show. He spoke so persuasively about the technology for optimizing antennas in an anechoic chamber and the miraculous properties of the gyro-stabilized parabolic antenna that all doubts were assuaged. Korolev lightened up and simply asked everyone to think things through one more time, to review the deadlines, and in 1 week's time show him the schedule. Korolev also took another step to clear the way for Soyuz. He ordered the factory manager, Turkov, to stop work on the new Voskhods and the experiments with artificial gravity, and to concentrate all his efforts on the Soyuz. But around this same time, the doctors called Korolev in again to visit the polyclinic in Moscow. In late November 1965, at the Ministry Collegium, an attempt was made to deal a crushing blow to OKB-1's style of operation as punishment for the disruptions of programs, primarily for the disruption of the Soyuz program. Not wishing to waste time delving into the shortcomings, Korolev very depthily beat off their attacks after showing them that OKB-1 failed to receive deliveries from the primary subcontractors. The vehicle hulls were empty. Assembly could not move forward. The schedules for experimental operations also had to be derailed. There had been no deliveries from the subcontractors, and the Ministry Collegium were berating OKB-1 rather than the subcontractors for their poorly organized operations. Korolev managed to fend off the first attack on the Soyuz program from the powers that be while he was still alive, but the Americans were once again pouring salt into Korolev's wounds. On December 4, 1965, Gemini 7 was launched, with 2 astronauts on board, Frank Borman and James Lovell. On December 15th, Gemini 6 was inserted into orbit, also carrying 2 astronauts, Walter Schirra and Thomas Stafford. The 2 American spacecraft performed an in-orbit rendezvous, They approached one another until 50 feet separated them. They did not risk approaching any closer, and there was no need. After all, they had no docking assemblies. The Soviets were once again blindsided by the duration of the flight. Gemini 7 stayed in orbit just less than 14 days, and in addition, the Americans demonstrated to the world their capability for rendezvous in space. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.